Now we're going to look at solving applied problems using the law of cosines. So just as the law of sines provided the appropriate equations to solve a number of applications, the law of cosines is applicable to situations in which the given data fits the cosines model. We may see these in fields of navigation, surveying, astronomy, and geometry, just to name a few. So here's our first example. On many cell phones with GPS, an approximate location can be given before the GPS signal is received. This is accomplished through a process called triangulation, which works by using the distances from two known points. Suppose there are two cell phone towers within range of a cell phone. The two towers are located 6,000 feet apart along a straight highway running east to west, and the cell phone is north of the highway. Based on the signal delay, it can be determined that the signal is 5,050 feet from the first tower and 2,420 feet from the second tower. Determine the position of the cell phone north and east of the first tower and determine how far it is from the highway. Okay, so let's go ahead and draw ourselves a nice picture for this. What we have is a tower here, a tower here, and then you have a phone. This is north and east. So here's the phone. So this is 5,050 feet. This is 2,420 feet. And this is 6,000 feet. Okay, so let's try to figure out what we're working with here. So what is our goal? Well, we don't know. We want to know how far the phone is from the highway. We want to know this distance here. So if we can find a right triangle like this, we can find this height here of this triangle. So there's a cell phone, and there's the highway down here. And we know this is 5,050. So if we can get this angle, we can use opposite over hypotenuse, call that theta, which is going to be sine, to find out what h is going to be. So let's find out what theta is going to be. So our side opposite of the theta is 2420. So if we go with what we saw before, I'm just going to write it this way. Let me erase that. So 2420 squared equals 5050 squared plus 6,000 squared minus 2 times 5050 times 6,000 times cosine theta. I was really tempted to use the other formula, but I'll just go with this. I'm much more familiar with this. So we end up with this 2420 squared minus the 5050 squared minus the 6,000 squared equals negative 2 times 5050 times 6,000 times cosine of theta. Again, we're trying to solve for theta, so I can divide both sides by the coefficient. So negative 2 times 5050 times 6,000 so this would divide out. Okay. And that's our cosine theta, so theta would be cosine inverse, or arc cosine, of 2420 squared minus 5050 squared minus 6000 squared over 2, negative 2, times 5050 times 6000. And what do we get from that? Approximately 23.3 degrees. Okay, so we can use that in our second triangle. 23.3 degrees. We know this is 50-50. We want the height. So sine of 23.3 degrees equals h over 50-50. So h is 50-50 times sine of 23.3 degrees. So what is h? Approximately 1997.5 feet. Okay, that was kind of fun. Now let's go on to another one. Suppose a boat leaves port, travels 10 miles, turns 20 degrees. So here's the diagram. It leaves port, travels 10 miles, turns 20 degrees, then travels 8 more miles. How far from port is the boat? So here we have a side angle side. We want to know the unknown side. So I mean, we can call that like our A. But I think you can see, I hope you can see, I guess I'll call this X. That this is the angle, oh, the angle opposite this is going to be, so that's 20 from the vertical. This must be 160 degrees. So our x squared equals 8 squared plus 10 squared minus 2 times 8 times 10 times cosine of 160 degrees. So x squared equals 314.35. So x is going to be the square root of 314.35. So x is going to be approximately 17.7 miles. That does it for this little video. We have one more to go. A really fun one, by the way.